Right. So, welcome to ACE Online and ACE Engineering Academy. I am here to discuss some of the important questions with analysis. Some of the important questions with analysis, especially for this GATE and ESE exam from the production technology subject. So, from the production technology, today I am going to discuss two important topics for your GATE and ESE exam. They are metal forming and sheet metal operation. Okay, na? I am going to discuss about metal forming and sheet metal operations. These two topics I am going to discuss. So, in the last week, I discussed the preparation strategy. In the last week, I discussed the preparation strategy for this production technology, especially from these two topics. And from that, you might be understand that there are only the formula-based questions they will ask you. Okay, na? So, for GATE and ESE exam point of view, mostly numerical questions they will ask you. They are formula-based questions. For GATE exam point of view, the questions are lengthy because calculator is allowed in the exam paper. That's why lengthy questions they will ask you. For ESE point of view, simple questions, numericals, you can solve those numericals without using calculator. This type of questions they will ask you for this ESE exam. And sometimes they will ask you some theoretical type questions also for ESE exam. Okay, na? For ESE exam. Right. So, now here today this 1 hour I will focus on numericals only, numericals and some theoretical type of question, so that you will get some confidence how to solve the questions. Okay, na? How to solve the questions, the type of questions we will discuss. So, in the role in the metal forming operations, these are the topics: rolling, wide drawing, tube drawing, extrusion and forging. And in the sheet metal operation, punching, blanking, deep drawing and bending. Okay, from these we'll discuss the questions, expected questions we'll discuss. Okay, now, right. Now, see here, this is one of the lengthy question, difficult question. Most of you people are confused with this question. Okay, now, most of you people, how to solve the question like that, most of you people are confused. But it's a question that is lengthy, maybe lengthy, but you can solve this question in a simple manner. You can solve this question. But some time it takes. Okay, na? Anyhow, I'll discuss the question and solution also. Now, see here, in this question is related to rolling operation. Okay, na? See, remember, in all metal forming operations, okay, the formulas, especially in case of ideal cases means ideal rolling, ideal extrusion, ideal wide drawing. For those conditions, those cases, they may not give the formulas. But actual cases based on the slab analysis methods are there. Na? So, for those slab analysis methods, definitely, mostly 90% they will give you numericals. And also one more important thing I will tell you, remember, for mechanical questions, for mechanical gate and ESE point of view, for mechanical gate and ESE, okay, for mechanical gate and ESE, the questions they asked only mostly from ideal cases, ideal metal forming operations. So, you should remember the formulas related to that. But for PI, sometimes in exam paper, PI exam, okay, actual cases they will ask you, okay, na, actual metal forming operations, these formulas like by using slab analysis methods, we should remember. So, be careful. So, means ultimately what I am saying, na, simple way. For mechanical, the questions are somewhat easy, but production questions are somewhat difficult. That's the thing. Right. Okay. Now, see here. The first question, if we consider this is a rolling operation, a 4 mm thick aluminum sheet. So, initial thickness of the sheet is given 4 mm and width, sheet of width 100 mm is given, width is given 100 mm, is rolled in a 2-roll mill of diameter 200 mm is given, 200 mm diameter is given. The workpiece is lubricated with a mineral oil which gives a coefficient of friction, mu is 0.1. Right. The flow stress of the material in megapascal. Remember, the flow stress is given. I will consider it is a YF. The flow stress is this one, 207 plus 414 epsilon, where epsilon is a true strain, and assuming rolling to be a plane strain deformation process. So generally rolling operation is a plane strain deformation process. Okay, na? The roll separating force for maximum permissible draft. Remember this is the maximum permissible draft is given in the question. This condition is given, you should remember this condition. And in the question formula also given, okay, roll separating force or rolling force formula is given, right? So simply if you substitute in this formula, you will get the answer. But in this question, initial thickness is given, but a final thickness is not given. Understand? Initial thickness is given, diameter is given, friction is given, but final thickness is not given. How to solve that final thickness? By using this maximum permissible draft. So remember, based on maximum permissible draft, there is a condition. Maximum permissible draft, there is a condition, that is delta H max is equal to mu square R. Delta H max equal to mu square R. So delta H is initial thickness is given, this I am assuming it as H naught is given 4, diameter is given 200, friction is given 0.1. So 4 minus H1, that is equal to 0.1 whole square into radius is 100. Okay, na? Diameter is 200, radius is 100. Diameter is 200, radius is 100. So from this you should calculate H1 first. So from this you should calculate H1 first. So you will get approximately, okay, H1 is 3 mm. So we got final thickness and initial thickness, first point. We got final thickness and initial thickness, that is one case. Second is, in the question, okay, the flow stress is given this one. But this is the average flow stress. Remember, I will write the formula. Okay, rolling force or roll separating force is what? Rolling force or roll separating force is what? 2 by root 3. Don't confuse. 2 by root 3 is nothing but 1.15 into sigma bar, or I am assuming here y bar f, it is average flow stress, into 1 plus mu L by 2H average into W into L. In the last week also I gave this formula, right? So in this formula I should substitute the data. Kada? Yes. Now in the question y bar f is not given. Remember, in the question instead of giving y bar f, in the question flow stress is given. So flow stress is equal to YF is equal to 207 plus 414 epsilon is given. Now from this we should calculate the average flow stress. From this we should calculate the average flow stress. Generally, listen carefully, average flow stress formula is generally for your exam k epsilon t power n by n plus 1. This is the formula, but in this question, this is the curve given. This is actually linear strain hardening. Linear strain hardening. This is a linear strain hardening equation is given in the question. So for a linear strain hardening equation, let us consider the stress strain curve. If we consider the stress strain curve is up to 207, there is no deformation in the material. Up to 207, there is no deformation in the material. From 207, it is a linear line. From 207, it is a linear line up to this epsilon t, that is epsilon t is equal to ln h naught by h1, that is ln 4 by 3. Okay, now, right, this is following 414 epsilon. This is following 414 epsilon. So if you want to solve this question, if you want to calculate the average flow stress, here we can't use this one. Okay, it's a linear strain hardening, right? So we should do the integration. Remember y bar f is equal to, okay, 1 by epsilon t into cyclic integration 0 to epsilon t into, okay, yf into d epsilon t. This is actually based on the energy conservation equation, means energy stored in the body is measured stress into strain, that is cyclic integration of 0 to epsilon t, the area of the stress strain core I am taking, stress into average strain. Okay, now, so actually question, if in the question if this is not given directly, you can substitute and you can solve, but here it is given, equation is given. So from this equation 1 by epsilon t into cyclic integration 0 to epsilon t, that is 207 plus 414 epsilon into d epsilon. Yes, no, epsilon t or epsilon. So from this you will get 207 plus 414 by 2 into epsilon. Very simple here. Direct also you can get. See, remember, average flow stress definitely half of this. This is the average flow stress. So 207 plus 414 epsilon by 2, right? 414 epsilon by 2. By substituting this equation, by substituting epsilon t is equal to ln 4 by 3, by substituting epsilon t is equal to ln 4 by 3, you will get the answer. Remember, because of the time constraints, sometimes I may not use calculator. I will directly substitute the values and then I'll leave that ns into 414 divided by 2 ns plus 207. So, sorry, plus 207. So 266.55 you will get. 55 megapascal you will get, right? So here I got average flow stress. Remember, this is my equation. Here I got average flow stress I calculated, and if I substitute, I'll get the answer. If I substitute, see here, rolling force is equal to 2 by root 3 into 266.55 into 1 plus maybe 0.1. L is length of the deformation zone. Remember, L is length of the deformation zone root of r into delta h, that is root of r is 100, delta h is 1, that is nothing but 10, right? 10 by 2 into h naught plus h1 by 2 into width of the sheet is 100, length is 10. So from this you will get the answer. Simple question. You will get the answer in terms of newtons, because this is in megapascal, this is in mm. So megapascal means Newton per mm square, okay, that is in mm square, so that you will get the answer in newtons. But in the question they are asking in kilonewton. By converting that you will get the answer. Good evening, engineering solution. Okay, now clearly getting? Okay, this is the lengthy question, that's why I'm discussing first. Once if you know how to solve this question, remaining questions are very easy. That's why I'm focusing this. This is the question last year they asked. Most of the people felt a difficulty to solve this question because it's a confusing question. Kada? Yes, na? So remember, same question, if friction is not given, substitute may be equal to 0. Simple. Same question, instead of giving rigid and strain hardened material, if a rigid and plastic is given, you take sigma y here. Simple. So that's why this is the lengthy question. Once if you understand this question, remaining questions are very, very easy. Remaining questions are very, very easy. That's why I explained this one. Right, okay. So because of the time constraint, okay, I am not writing the answer here directly. I am going to the second question. Next. In a rolling of a flat strip, the relative velocity of strip with respect to the rollers. This is the question, actually gate question, previous gate question. So remember, I will give you the clear idea here. Remember, listen carefully. In the rolling operation, I will give you the velocity profile, slip profile, and pressure profile. From that, there may be a chance to ask a question. Now, listen carefully, okay? This is the entry of the deformation zone. This is the exit of the deformation zone. So, entry I am representing with A, exit I am representing with B. At entry of the deformation zone, the velocity of the strip is V0. At exit of the deformation zone, velocity of the strip is V1. And the roller velocity I am considering that is a constant velocity VR. Now listen, in the deformation zone from A to B, the velocity of the strip is keep on increasing. There is a minimum velocity at entry. And the velocities keep on increasing because the deformation is going on. And at neutral plane, the velocity of the strip is equal to the velocity of the roller. At neutral plane, velocity of the strip is equal to the velocity of the roller. And after neutral plane, again the velocity of the strip is keep on increasing. So remember, I am dividing this into two zones. One is lagging zone. This is leading zone. So they will ask you for your exam either velocity profile or a slip profile or a pressure in the deformation zone. That's why I will discuss all the three profiles here. Let us consider a graph. This is A, that is entry of the deformation zone. This is B, that is exit of deformation zone. And I am considering this is a neutral plane. Now here I will explain two profiles. One is a velocity profile, second is a slip profile. So first let us consider velocity on y-axis and deformation zone on x-axis. Length of deformation zone on x-axis, length of deformation zone on x-axis, and velocities on y-axis. Now listen carefully, the roller velocity is constant. See here, this is the roller velocity, that is a constant. VR is roller velocity is constant. But the strip velocity or a plate velocity V0 is minimum, and it is keep on increasing. At neutral plane, V0 is equal to VR at neutral plane, and this is final V1. So this is the velocity profile. Okay, now what do you mean by slip? Slip is nothing but relative velocities here. Relative velocity of strip with respect to the roller. Remember, slip is nothing but relative velocity of strip with respect to the roller. Velocity of strip minus velocity of roller by velocity of roller into 100. This is the slip. Now, if I consider the lagging zone, in the lagging zone, velocity of strip is less than the velocity of roller. The two difference is more. So more slip is present at entry. And with moving into the deformation zone, the velocity difference is decreasing. So slip is decreasing and slip is 0 at neutral plane. Slip is 0 at neutral plane and slip is keep on increasing again here. So now from this, listen, I will give you, this is a negative, okay, this is a positive. Slip is decreasing, slip is increasing. This is a negative profile, this is a positive profile. Okay, that is a negative profile and this is a positive profile. Slip is decreasing and slip is increasing. So from this question, negative at entry and positive at exit. Right. Now if we consider a pressure, pressure is minimum at entry, pressure is minimum at entry, pressure is keep on increasing, and in neutral plane pressure is maximum, pressure is decreasing. So remember, in the lagging zone pressure is increasing, in the leading zone pressure is decreasing, and maximum pressure point we call it as a friction hill. This maximum pressure we call it as a friction hill. Remember, this is the information. Yes, good evening, MSR, good evening. Right. So from this, there is a chance to ask a theoretical type question. That's why I'm explaining. Remember, in the rolling operation, the velocity of roller is constant. Velocity of strip is keep on increasing. And at neutral plane, velocity of roller is equal to velocity of strip. First point. And if you talk about a slip, slip is maximum at entry and exit. And the slip is decreasing in the deformation zone. And at neutral plane, slip is 0. And it is keep on increasing. And opposite to the slip, there is a pressure. So remember, pressure is proportional to 1 by slip. Pressure is proportional to 1 by slip. This is the information about, okay na? This is the information about pressure and slip. Right, next question. See, this type of questions also they will ask you. See here, a 80 mm thick steel plate, 80 mm thick steel plate, this is initial thickness, with a width of 400 mm, is rolled to 40 mm thickness in 4 passes. 40 mm thickness in 4 passes. This is H final. Remember, number of passes is given. I am not asking a simple question. This is somewhat a question, a difficult question only. If you don't know, you can't, very difficult. Equal reduction in each pass. By using a rolls of diameters for 800 mm, radius is 400. Assuming the plane strain deformation, what is the minimum coefficient of friction required to unaided rolling to be possible? So if you want to perform the rolling operation, what is the minimum friction? See, if you want to calculate the friction, there is a formula, delta H max is equal to mu square R. This is the formula. But remember, this is the delta H max per pass. This is per pass. In one pass, what is the reduction? Right. But in the question, 80 mm thickness to 40 mm thickness in 4 pass. So that 80 minus 40 by 4 passes, because in each pass there is an equal reduction is given in the question. In each pass there is equal reduction is given in the question. So 80 minus 40 by 4, that is 40 by 4, that is 10, that is equal to mu square into R, that is 400. So mu is equal to under root 10 by 400. So what is the answer? Under root 10 by 400, that is 0.158. This is a question, simple question. Okay, simple question. This type of questions they will ask you. See, some of you people will do like this directly. That's why intentionally I gave 80 minus 40 is equal to mu square into 400. If you don't know, you'll not get. Be careful. Be careful. This is not the solution. Getting everyone? Right. Next question. Now, another question. See here. A 4 mm thick sheet is rolled using a 2-high rolling mill to reduce the thickness under a plane strain condition. Both rolls have diameter of 600 and rotating at 200 rpm. The coefficient of friction at the sheet interface at the sheet and roll interface is 0.1. The elastic deflection of roll is negligible. If the minimum flow strength of the sheet metal is 400 megapascal, then Minimum possible thickness you are asking. Remember, when will you get a minimum possible thickness? Tell me. Minimum possible final thickness. Initial thickness is 4 mm. Okay, remember, initial thickness is given 4 mm. He want final, okay, minimum thickness he want. When you will get, tell me. If there is a maximum possible reduction in one pass, if it is maximum reduction, then you will get minimum thickness at the final. See, the formula is delta H max. This formula is very, very important. Mu square R. Delta H max is what? H naught minus H1 max. H naught minus H1 max is equal to mu square R. Here, if I want to get minimum, see, remember, this should be maximum. Okay, total if I want to maximum, this should be maximum, this should be minimum. That is equal to mu square R. Now, maximum is 4 is given in the question, initial thickness, that is constant. Now, H minimum is equal to mu square, mu is 0.1 whole square into R is, diameter is given 600, so R is 300. Right? So, from this you will get H minimum. From this equation you will get H minimum is equal to 1 mm, I think so. Simple question here, very, very simple question. Very, very simple question. Right? So, in this there are unnecessary data, so much data is given. This is okay, this is given, right? So, you people will fear, but don't fear. It's a simple question, minimum possible thickness, maximum. Sir, more friction option B. Yes, correct. Friction option B, MSR, correct. Okay, na? Right. So, this type of questions they will ask you from the rolling, remember. Okay, sometimes questions they will ask you bite angle also. So, this is an extrusion type question. This is also lengthy question, but in the question, formula is given. You should be very happy. Yes, formula is given. But remember, formula is given now, there may be some trick. Okay, be careful. Mostly for actual questions, formula they will give. Ideal cases they may not give. Okay, na? So this is the question, formula given. How to solve this question, I'll explain. A cylindrical billet of 100 mm diameter. So initial diameter is 100 mm. Is extruded to produce an I section. So they are going to make an I section from cylindrical billet. Billet diameter is given 100 mm. So D naught is equal to 100 mm. And from this cylindrical billet, we are going to make like this component. So here, listen carefully, initial area A naught is equal to pi by 4 into 100 whole square, you should solve. Then final area we are making I section B. So here I am calculating the area. Remember this 250 into 2, that is 500 into 5 into 60. This is 5 into 60. So 5 into 60, 300. So 800 mm square is the final area. This is the initial area, this is the final area. And the total extrusion pressure in megapascal required for the above process is given. Formula is given in the question. Remember. Okay, formula is given. Next, where sigma m is the mean flow stress of the material, A naught and AF are the final areas. If the mean flow stress of the extruded material is 100 megapascal, so mean flow stress also given. The force required for the above extrusion process, force they are asking in kilonewton. So some of you people will forget, they are asking force, but you will substitute in the equation and you will get it out from that. But listen, force they are asking. See, remember, extrusion force is equal to, okay, extrusion pressure or a ram pressure into initial area A0, because we are applying force to initial billet material. Right, what is the formula is given ram pressure? Sigma m into 0.8 plus 1.2 ln A0 by AF. A0 by AF. This is the formula into A0. Sigma m into 0.8 plus 1.2 ln A0 by AF into A0. Now see here, 100 into 0.8 plus 1.2 ln A0 is pi by 4, 100 square by 800 into pi by 4, 100 square. That's it. This is the answer. Tell me, what is the answer for this question? Tell me, MSR, Engineering Solutions, what is the answer for this question? What is the answer for this question? Simple question. Okay, now I am not solving, but I am not using calculator. It takes time. That's why just explaining. Instead of that, one more numerical we'll discuss extra. Right? That's why. So this type of questions they will ask you. Okay, simple questions. See, remember, metal forming and sheet metal operation, gate questions are very easy. Numerical based questions, if you remember the formulas, easy. Only remember the formulas. Sometimes even in the question paper, formulas also giving. Happy na? Very happy. Only in case of ideal cases, formulas they may not give. In case of ideal cases, they may not give the formulas. Remember that. Right, next question. Now see here, another question. A metallic strip having a thickness of 15 mm, initial thickness is given 15 mm, is to be rolled using two steel rolls of each 900 mm diameter. Okay, it is assumed that there is no change in width of the strip is constant. In order to achieve 10% reduction in the cross-sectional area of the strip after rolling, the angle subtended in degrees by the deformation zone. Simple question here, bite angle they are asking, angle of bite they are asking. So generally, what is the formula of angle of bite? Tell me. Tan alpha is equal to root of delta H by R, formula. Yes, na? But initial thickness is given, H0 is given 15 mm. Final thickness is not given. Final thickness is not given, and they are saying that width of the strip is constant. W1 is equal to W0. There is no change in width. There is no change in width. W1 is equal to W0. There is no change in width. Yes, na? Right? So, width of the strip is constant. But they are saying reduction in cross-sectional area is same. Okay? Reduction in cross-sectional area of strip after rolling and before rolling is same. See, sorry, 10% reduction, right? So, remember, initial area, A0 I am assuming, in order to achieve 10% reduction, okay, I am assuming initial area A0, final area A1. So, A1 is equal to 90% of A0. Remember, 10% reduction means remaining 90% left. We are reducing 10% reduction in cross-sectional area means remaining 90% left. That's why I am writing A1 is equal to 0.9 into A0. And A1 we can write it as H1 W1 is equal to 0.9 into H0 W0. W1 cancel out. So H1 is equal to 0.9 times of H0. That is equal to how much? That is equal to 0.9 into 15. That is equal to 0.9 into 15. Okay, na? 0.9 into 15 is 13.5. Right. Now, see here, H1 we got. So, tan alpha is equal to root of delta H, reduction in thickness. So, 10% means H0 minus H1, 15 minus 13.5, 1.5 by or 450. Now check it. What is the answer for this question? 1.5 divided by 450. Tan inverse 3.3. So B is the correct answer. Alpha equal to 3.3 degrees. B is the correct answer for this question. It's a very simple question. Sai, tell me, is there any doubt? Sai? Right. Next, another question. Now, this is a question that is very, very important for your exam. Okay, competitive exam, any competitive exam, this is a very, very important. The maximum reduction in cross-sectional area per pass of cold wire drawing process is R is equal to 1 minus e power minus n plus 1. Very, very important formula. In the question itself, I am giving the formula. Happy na? Now, where n represent the strain hardening coefficient, for a case of resident strain hardened material with n equal to 0.28. Simple question here. N value also given. R is equal to 1 minus e power minus n plus 1. If I consider n is equal to 0.828 if I substitute, R is equal to 1 minus e power minus 0.28 plus 1. Simple. Okay, you will get 0.722. Okay, in the previous year gate question, instead of giving the value of n, in the question rigid and plastic is given. Rigid and perfectly plastic is given. For a rigid and perfectly plastic, n equal to 0. Remember, in the question, in the previous question, instead of giving n value, rigid and plastic is given. I modify that question. So n is not given, but it is said in the statement is said rigid and plastic material. For rigid and plastic material, strain hardening exponent is 0. So if I substitute n equal to 0, I will get 63.2. That is important. In a wire drawing process, especially for rigid and ideal wire drawing operation, maximum possible reduction for rigid and plastic metal is 63.2. Okay, na? 63.2. Right. Next question. Now see here, listen carefully. A workpiece of 30 mm diameter and 40 mm height is compressed between two platens in an open die forging process. Assume a perfectly plastic material with a flow stress of 250 megapascal. The ideal forging operation, forging load at a 25% reduction in height. Now see here, initial diameter, a workpiece of initial diameter, listen, D0 is given 30 mm and D height is given, H0 is given 40 mm, is compressed between the two dies. Assume a perfectly plastic material, so flow stress is given or yield stress is given. Perfectly plastic material, average flow stress is nothing but yield stress is given. Ideal forging operation at a 25% reduction in height. Remember? So height HF is equal to 25% reduction in height means 75% left. So 0.75 into 40 HF. Okay, 0.75 into 40, that is the HF. Right, from this, listen, calculate dF square HF is equal to D0 square H0. So calculate dF, that is equal to d naught into under root h naught by hf. Okay, I am not solving, okay, now because of the time constraint. 30 into under root h naught is 40, 40 by 0.75 into 40. And we know that the forcing force, ideal forcing force, okay, forcing force is, it is not average, it is just a flow stress. Okay, we should not use average flow stress, YF into AF. Generally, there is a formula, YF into AF plus 2 mu RF by 3 HF, but in the question friction is not given. So mu equal to 0, that's why I am directly writing YF into AF. So YF is given 250 into AF is pi by 4 d square. This is 30 into under root 1 by 0.75 whole square. By solving this, you will get the answer. Right? So this type of questions they will ask you from the forcing. If you remember this formula, that is more than enough. Any type of question you can solve. By remembering, in forcing, any type of question you can solve. Right. Now, this is a question actually from sheet metal operation. Now see here, a rectangular hole of size 100 mm by 50 mm is to be made. So this is a sheet. In a sheet we are going to make a hole 100 by 50 hole is to be made in a 5 mm thickness, 5 mm thickness of the sheet, having an ultimate tensile strength and shear strength. So we should not use the tensile strength here. We should use the shear strength to calculate the force. Punch force, we should use the shear stress because the sheet metal is failed by the shear. The hole is made by punching process. Neglect the effect of clearance, the punching force. So remember, for IS exam point of view also, this type of questions they will ask you. Perimeter into, remember, okay, sheared area into ultimate shear strength. Sheared area is perimeter A plus B, that is 2 into A plus B is the perimeter into thickness into tau u. Right, now here 2 into 100 plus 50 into thickness how much? 5 into ultimate shear strength 300. That's it. That is 2 into 150 into 5 into 300. By solving this, you will get the answer. Right, now approximately we'll get 450 kilonewtons answer. This is in terms of newtons. This is in terms of newtons. So remember, it's very simple. 30, 2 into 15, 30, 5 into 3, 5 3 is a 15, 15 3 is a 45. So 450 answer you'll get without using calculator. This type of questions they will ask you for your ESE exam, other competitive exam. Recently there was a question, there was an exam recently, I think Sunday or some other day. So there is a question they asked from this model, maximum punch force. So this concept is very, very important, okay, na, for your exam. Right. Next, another question. This is a gate question directly I am giving. Now see here, a 25 mm diameter hole is pierced. Piercing is nothing but punching. In a sheet of thickness 2.5 mm, sheet thickness 2.5 mm, diameter is given 25 mm. Shear strength is given, that is 350 megapascal. Tau u is given, shear 350. If the diametrical clearance is given by the expression, C is given, diametrical clearance. The die diameter, punch diameter and punching force. See, remember, first of all, is it is punching or blanking? Tell me. If you want to calculate the dimensions of a punch and die, first you should decide, is this is a punching operation or blanking operation. Okay, na? In case of punching operation, in the question it is given pierced. Diameter hole is pierced in a sheet, right? So I am considering it is a punching. right? In case of punching, remember, clearance is provided on a die. In case of punching, clearance is provided on a die. So punch size is equal to hole size. Die size is equal to punch size plus diametrical clearance. So punch size is equal to hole size, that is 25 mm. So die size must be greater than 25 mm. Simple. Now check it, option check it. So in the question, respectively, first die diameter, second punch diameter, third punch force. Kada? Yes, na? So die diameter. Now if we go through these options, okay, die diameter should be more than 25. So die diameter 25 is given, wrong. Die diameter 25 is given, wrong. Die diameter is given less than 25, wrong. So this is the only one answer. Calculations also not required. Simple. Punching operation. In punching operation, punch size is equal to hole size. Clearance is provided on die. So die size is equal to punch size plus clearance. So always die size is greater than punch size. How much amount? Clearance amount. So punch size is a 25, die size must be greater than 25. Right? Right. That is next. So simple questions here, very simple questions. Now see here. A hole of 40 mm diameter is pierced. Pierced means punching. So in the question, diameter is given 40 mm. In a steel sheet of 4 mm thickness, thickness of the steel sheet is given 4 mm. Without shear on the tool, first without shear. Next, shear strength of the steel is 400 megapascal, tau u is given. And penetration is 25%. Okay, penetration is 25%. What is the expected percentage load reduction? Remember, this is important. Percentage load reduction. Percentage load reduction if a shear is provided. So two cases ikkada. In this case, in this numerical, two cases. One is without shear, second is with shear. So remember, listen carefully, percentage load reduction. Percentage load reduction, if I want to get, what is the formula? F max without shear minus F shear by providing shear, load by providing shear, divided by F max into 100. F max into 100. Right. Now, listen. Fs is equal to F max into penetration thickness by penetration thickness plus shear. Now see here, F max into penetration is 0.25 into 4 mm thickness by 0.25 into 4 plus shear is 2. Shear is given in the question 2. Penetration is given 25%. Shear is given in the question 2. Penetration is given 25%. So 0.25 into 4, 1. 0.25 into 4, 1. So 1 by 1 by 3. So 1 by 3 into F max. Yes, na? Now from this, percentage load reduction is equal to F max minus 1 by 3 F max, that is 0.33 by F max into 100. So by solving this 66.67, you will get D is the correct answer. Now getting? It's a simple question only, without calculator. IS also, for IS also, this type of questions they will ask you. Without using calculator. So percentage load reduction they are asking. Without considering shear, with considering shear, so F max minus Fs by F max into 100. So like that, we should solve the question. Okay, now next, another question. that is related to the blank size and die size, these questions. Now this is a deep drawing, okay na? Now a cylindrical cup of 48.5 mm diameter, this is the initial diameter d naught or a cup diameter d small d, and height is 52 mm, height is 52 mm, as a corner radius 1.5 mm, RC is given, corner radius. Cold rolled steel sheet of thickness 1.5 mm is used to produce a cup. Assume trim allowances as 2 mm for a 25 mm cup diameter. This is important. That's why I'm explaining here. See, listen carefully. I want to calculate the initial blank size. This is the initial blank, circular blank. From this blank, I should make a cup. Remember, from this blank, I should make a cup. Cup diameter is given in the question, D and H. D and H is given. Right? So, diameter of the cup is much more than the radius of corner radius. That's why I'm neglecting the corner radius. Diameter of the cup by corner radius is greater than 20. That's why I'm neglecting the corner radius. Now, blank diameter, if I want to calculate, remember, blank diameter, if I want to calculate, in the last session also I gave how to find that by considering one side surface area of blank to the outside surface area of cup. So from this, d square plus 4dh you will get. So d square is nothing but a cylindrical cup 48.5 square plus 4 into 48.5 into height is 52. So from this blank diameter you will get. From this, remember, blank diameter you will get, that is 48.5 square plus 4 into 48.5 into 52. That is 111.53 mm. But it is not the correct answer. Because in the question trimming allowance is also given, you should add the trimming allowances also. But in the question trimming allowance is given, 2 mm trimming allowance you should provide for 25 mm diameter cup. But we have diameter of the cup 48.5. So that, remember, trimming allowances is equal to 2 by 25 into 48.5. By, for a 25 mm diameter cup, 2 mm allowances. For us, 48.5 mm diameter cup manaki. Yes na? So from this you will get the blank diameter is equal to 111.54 plus 2 by 25 into 48.5. So from this you will get the approximate answer, that is 115.4. That is 115.4 you will get the answer. Okay na? Simple question. This type of questions only they will ask you for exam. Right. Now, listen, a percentage scrap, here I will frame a question, diagram I will frame. Listen, this is a sheet. In a sheet, I am going to make a rectangular blocks. Okay. The rectangular blanks here, let us consider, or a square blanks I am considering here. This is A and A. Let us consider this is A by 5. This is A by 5. This is A by 5. This is also A by 5. So I am going to make a rectangular square blanks of size side length A. I am going to make a square blanks of side length A. What is the percentage scrap? Remember, percentage scrap, I think in the last session I was not given the formula for this strap strip layout. Percentage scrap is equal to total area how much we used minus actual area to make a blank by total area. Right. Now total area how much we are using here? Listen carefully. total area, how much we are using, that is important. Now see here, the total area we are using this much. Listen carefully. One side scrap we should give, and A by 4, A by 5 plus this and this one. Total area is A by 5 plus A into 2A by 5 plus A. That is 6A by 5 into 7A by 5. Right? And actual area is equal to A square. Now percentage scrap is equal to 1 minus A square by 6 into 7 by 25 A square. So from this you will get 25 by 1 minus NS, 40.4, 0.404. So percentage scrap means 40.4 you will get percentage. So this is the strap strip layout numerical, okay na, strap strip layout numerical. So these many questions I discussed, important questions for your exam I discussed, okay. So that's why I'm saying for ESE and GATE exam point of view, mostly from this metal forming operations, they will ask you the numericals, okay. Numerical based questions, they are very simple questions they will ask you. You no need to worry. If you remember the formulas, you will get. Not only GATE and ESE, any competitive exam you take, ISRO, DRDO, BARC, BDL, right? Any competitive exam, simple questions, formula based questions without using concept also sometimes not required. Just remember the formula. Even for those questions, sometimes calculator also not required. For GATE exam, calculator is required, some lengthy question they will give. For other competitive exam, from these two topics, they are easy questions they will ask you. So be focused on these two topics, and all the best for your exam.